Back in 1978, Ben Cohen and Jerry Greenfield started making homemade ice cream out of a renovated gas station in Burlington, Vermont. But there was a unique biological hurdle right from the start. Ben actually had a severely reduced sense of smell, which meant he couldn't taste very much either. To compensate, he relied heavily on mouthfeel. He mandated that their ice cream had to be packed with massive, irregular chunks of cookies and brownies to provide physical texture instead of relying purely on flavor. Those colossal mix-ins quickly became the signature hallmark of the brand. But while that quirk works well in a small gas station kitchen, it creates a massive mechanical nightmare if you want to scale up. Decades later, that local shop has grown into the best-selling single-brand ice cream label in the United States. This chart shows the sheer leap in production. Today, the Vermont factories operate 24/7 to pump out nearly 1 million pints a day for freezers across 38 countries. Which brings us to the central engineering problem. You have to somehow force those massive, irregular chunks of dough and chocolate through high-speed industrial machinery without jamming the entire system. The only way to achieve that scale without destroying the product is by running a strictly controlled thermodynamic pipeline, carefully managing the physical state of the ice cream from a raw liquid down to a deep freeze. Everything starts with the raw materials, specifically the milk. Even at this scale, the milk is sourced from a cooperative creamery just a mile and a half from the factory. Once it arrives, the milk is stored in massive 6,000-gallon silos before heading to the blend tank where the factory churns through 6,700 gallons of cream and sugar every single day. From there, the mixture is piped straight into the pasteurizer. Inside, the liquid base flows rapidly over hot steel plates, heating up just enough to kill any harmful bacteria. After pasteurization, the liquid doesn't go straight to the freezer. It's routed into a holding tank where it sits undisturbed for 4 to 8 hours. This resting phase provides a crucial chemical window, allowing the ingredients to properly bind together and stabilize before they hit freezing temperatures. Once the base is stabilized, it moves into one of 20 different flavor vats to get its specific identity, like Cherry Garcia or Chocolate Therapy. The company also uses these vats to mix up flavors dedicated to social advocacy, naming products to draw attention to causes like criminal justice reform and refugee protection. Next, the flavored liquid is pumped through a giant freezing barrel. By the time it reaches the front of the barrel, the temperature of the mix has plummeted to exactly 22 degrees. At this precise temperature, we get a rapid state change. The liquid instantly transforms into a thick, highly viscous soft-serve consistency. Now the factory has to solve the chunk problem. Workers stationed at a mechanical chunk feeder begin manually dumping heavy globs of cookie dough, brownie bites, and nuts directly into the moving stream. Timing this injection at this exact 22-degree state is critical. The soft serve is finally thick enough to grip the heavy chunks and suspend them evenly, keeping them from just sinking right to the bottom of the vat. With the chunks firmly suspended, the mixture enters a high-speed packaging gauntlet. An automatic filler drops empty cardboard containers into position and pumps in the ice cream at a rate of 270 pints per minute. But running highly textured ice cream through a machine that fast creates immediate risks. The rapid filling can easily trap empty air pockets or result in uneven, lightweight pints. To catch these errors, quality assurance workers pull 6 individual pints off the line every hour, slice the cardboard completely open, and cut the block of ice cream right down the middle. This cross-section shows what they look for. They ensure chunks are dispersed symmetrically and verify a minimum weight of 460 grams. They also examine the edges. A tiny gap is an acceptable functional void, but a massive air bubble is a critical structural failure. This aggressive manual auditing is the only safeguard the factory has. It ensures they can maintain mass-scale uniformity without ever sacrificing the dense, chunky texture the founders demanded. Once the pints pass inspection and are sealed tight, they are sent into their final and most extreme thermal environment, the spiral hardener. Inside, a towering corkscrew conveyor belt forces the pints through a blasting freezer, where the wind chill drops down to -60 degrees. Every single pint is subjected to this freezing gauntlet, traveling continuously along the spiral for 3 full hours. This deep freeze acts as a structural anchor. It permanently locks the soft serve base and the suspended chunks into a rigid, stable architecture that can survive the long, unpredictable journey of global shipping. Finally, the rock-solid pints are flipped over and shrink-wrapped together into groups of 8. Since each group equals exactly 1 gallon, they are ready to be loaded onto pallets. But you'll notice you never actually see a single 1-gallon tub of this ice cream sold in a grocery store, which seems counterintuitive for a massive industrial food company. The reasoning comes down to preserving that carefully engineered structure. Large bulk tubs tend to sit forgotten in the back of consumer freezers, collecting damaging ice crystals and slowly degrading the texture. By restricting the packaging solely to smaller, single pints, the company effectively forces a faster consumption rate in the home, ensuring the product is eaten before the quality can deteriorate. From the thermal suspension to the pint-only packaging, the factory is a system designed to protect the original artisanal quirks of its founders at a global scale.